Systems verify ready for launch. FTS.
FTS go.
Props go. ABI.
ABI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Good morning and welcome to our live coverage of the Transporter 16 mission. Falcon 9 is currently scheduled to lift off at 4:02 a.m. Pacific from Space Launch Complex 4 East at Vandenberg Space Force Base, which is just north from us here in Hawthorne, California. My name is Tyler Lionquist and I'm a Starlink business analyst here at SpaceX. There are 119 payloads on this flight, including CubeSats, microsats, hosted payloads, a re-entry vehicle, and orbital transfer vehicles, carrying 8 of those payloads to be deployed at a later time. All spacecraft on board today will separate from Falcon 9's second stage across 82 deployment events, scheduled to start around T+54 minutes and conclude about 2 hours and 32 minutes after liftoff. SpaceX has launched more than 1,600 payloads to orbit across our entire rideshare program. And for more information on what's flying today, we have a full list of payloads available on spacex.com/launches. Right now, the weather is currently green on the Central Coast, and the range is ready to support. And if needed, there is a backup launch opportunity available tomorrow during the same window. So while the countdown continues, let's take a moment to learn more about Gravitas, the payload at the top of today's stack, manifested by K2 Space.
What the future of space travel looks like, it's large scale, it's infrastructure applied at a cosmic scale. And for that, we needed to build bigger. K2 was built to do that from the very beginning. Satellites should be higher power, they should be able to host payloads with larger aperture, and they should be able to host payloads that are more massive. The reason for that is those 3 things directly affect every bit of mission performance. The Gravitas mission builds off of our demo mission that we launched earlier this year, takes a lot of those components, scales them up across the entire satellite, and launches a full spacecraft with customer payloads to demonstrate an end-to-end mission with high power in the orbits we intend to fly in long term. So really bringing everything together. Building a satellite like the mega-class satellite at K2 is an enormous engineering challenge. Not only are there 50 new systems you have to invent that don't exist yet, the physics of building a satellite of this scale are just extremely unforgiving. You're building extremely high power systems that are very, very large. You need to design everything from gigantic reaction wheels to super high power Hall thrusters. But I think the challenges that face K2 from an engineering perspective broadly fall into 3 categories: propulsion, power, and radiation. Propulsion is how do we get to the orbits that we're trying to get to? How do we take a gigantic satellite and move it from one orbit to another? That's where the systems like the Hall thruster that we're building are really game-changing for the entire industry. We're building the highest power Hall thruster that's ever flown by a factor of 4. That's a very, very intense engineering challenge. On the power side, you have to build gigantic solar arrays and maneuver those solar arrays as you're trying to point in space, control the momentum that's being accrued from having those gigantic solar arrays. In addition, you have to have high voltage systems that can take the power that's being generated from those solar arrays and convert it into useful energy for the spacecraft. These are all incredibly hard challenges for electrical engineers to solve. It's still a demo mission. It's experimental. The goal is to get as much data as possible out of this mission and to learn as much as possible as we look towards the missions coming up next.
At SpaceX, helping to keep Earth orbit safe for everyone is a top priority, and we're committed to leading the industry in space safety, especially during rideshare missions like today's, where dozens of payloads will be deployed in a short period. Ahead of every launch, we perform a COLA, or collision avoidance screening, to ensure the safety of the rocket and payloads during the launch and deployment sequence. But pre-launch screenings are only valid for a few hours after orbital insertion. So we're working to bridge what we call the launch COLA gap, or the period of time after that pre-launch COLA screening ends, but before ground-based sensors can reliably track the satellite. We encourage satellite operators and other launch providers to join us in our effort to keep space safe and sustainable, sharing ephemeris or orbital data as soon as possible once in orbit, and keeping other satellite operators updated with high-accuracy ephemeris throughout the satellite's lifetime. As you can see in this animation, this data helps operators to predict and deconflict potential collision events. Think of it like directing air traffic here on Earth. At any point, there are tens of thousands of planes traveling around the globe. Those aircraft are broadcasting their location and flight plan to keep airspace safe. And the same needs to be true in space. When satellite operators continuously share their satellite's ephemeris data, it allows other satellite operators to detect upcoming close approaches sooner and more accurately, and perform collision avoidance maneuvers if necessary. So with everyone's support, we can bridge that launch COLA gap and mitigate any risk to orbiting spacecraft, ensuring a safe environment for humanity to explore Earth orbit and beyond. For more information, or to go register your payload with SpaceX's conjunction screening service, visit starlink.com/satellite-operators.
Engine chill.
The Falcon 9 rocket supporting today's mission is a two-stage rocket designed for the reliable and safe transportation of satellites, cargo, and people. Starting from the very top of the rocket, we have the payload fairing. The fairing is a protective shell that houses all the payloads, shielding them from aerodynamic heating until the vehicle is outside of Earth's atmosphere. The shape of the fairing contributes to Falcon 9's overall efficiency, helping to reduce drag during flight. And within that fairing is today's payload stack. Here is a photo from midway through the encapsulation operation,
RP1 load is complete.
just before the fairing halves were closed in preparation for flight. And here's a live view of that payload stack. Once in space, the two fairing halves separate and fall back to Earth, where they will be recovered by our recovery vessel to be refurbished and reused on future flights. Both halves of the fairing are flight proven, with one side flying for its 25th time and the other for its 22nd. And right below the fairing is Falcon 9's second stage, which features a single Merlin vacuum or MVAC engine. Below the second stage is the black carbon fiber interstage, and inside of that is where the MVAC engine is located. And below that, we have the first stage, or booster, which will be fully loaded with about 1 million pounds of liquid oxygen and RP1 rocket-grade kerosene. And that first stage supporting today's mission will be making its 12th flight today. It previously launched the SDA T1TLB and SDA T1TLC missions, and 9 Starlink missions. And the first stage makes up the bottom 2/3 of the vehicle and has 9 Merlin M1D engines at the bottom, which generate more
Falcon
than
9 tanks are pressurizing for strong back retract.
1.7 million pounds of thrust. And about 2.5 minutes into flight, the first stage will separate and make its way back to Earth. And today that booster is headed towards our drone ship, Of Course I Still Love You, which is currently stationed in the Pacific. Now, coming up next, the truss structure next to the vehicle, known as the strongback or the transporter erector, will start to retract. And in preparation for
retract has started.
So in preparation for retraction, the clamp arms around that second stage will open, and then the strongback will begin to recline away from the vehicle. You can see them start to open now, just underneath the payload fairing. Once those are out of the way, then the strongback can recline back away from the vehicle and give it room for liftoff. Now that those clamp arms are fully open, the rocket is fully free at the top.
Stage 1 lock load is complete.
Pogo.
And we just heard that call out that liquid oxygen loading for the first stage has finished, which finalizes propellant loading for the booster. At T-minus 2 minutes and 42 seconds, all systems are currently a go for an on-time liftoff. Rideshare missions like today's significantly increase access to space for small satellite operators around the world, and we're excited to be able to offer these launch opportunities for our customers. In addition to helping drive down the cost of access to space by flying reusable vehicles, dedicated rideshare flights provide small satellite operators competitive pricing, increased flight opportunities, and flexibility. Overall, SpaceX's rideshare program has enabled our customers to iterate on their technologies and grow at scale. There are all types of spacecraft on these missions. Everything from payloads for the U.S. government, to constellation deployments, to technology demonstrators, to re-entry vehicles. We've also seen several countries launch their first spacecraft ever on board transporter missions, tons of student efforts, and even a father-daughter CubeSat project.
Stage 2 lock load is complete.
And there we heard that the liquid oxygen for the second stage is now fully loaded, completing prop load for the upper stage. And for more information on SpaceX's
Ground gas closeouts.
For more information on SpaceX's rideshare program, visit spacex.com/rideshare.
Falcon 9 is in startup.
At this point, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 are pressurizing for launch.
Launch director, go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff, Falcon 9. Go SpaceX, go Transporter 16.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
At T plus 30 seconds into flight, Falcon 9 has successfully lifted off from Space Launch Complex 4 East at Vandenberg Space Force Base. We're currently throttling down to prepare for max Q, which is the point of maximum aerodynamic stresses on the
Power and
vehicle.
telemetry nominal.
Max Q is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket.
Falcon 9 is supersonic.
So now we're just waiting to hear that call out for max Q.
Max Q.
And there was our call out. So Merlin engines are back at full power, and we're out of the throttle bucket. From here on, even though velocity is rapidly increasing, the atmospheric density is decreasing, resulting in less loads on Falcon 9. And coming up next, we'll have several events happening in quick succession, starting with MECO, followed by stage separation, and second engine start.
Chill.
And second engine start, or SES1. Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation, which is where the first stage separates from the second stage. Then the MVAC engine on the second stage will light, which is called out as second engine start 1, or SES1. This engine burn, lasting several minutes, will propel the second stage and our payloads to orbit. After that, the fairing will jettison from the second stage, as it's no longer needed to protect those payloads once we're in space. So we should be hearing the first of these callouts in just a few moments.
Main engine cut off.
Stage separation confirmed.
MVAC ignition.
And there you heard and saw those three events that happened back to back, including main engine cutoff, stage separation, and second engine start 1. Coming up next will be fairing separation.
Fairing separation confirmed.
And there we heard confirmation of fairing separation along with a great view of those two halves separating from the vehicle on your screen. And as a reminder, those fairings will be making their way back to Earth for recovery. The next major milestone coming up is entry burn on our Falcon 9 first stage, which is scheduled to occur around the T+6 minute mark. The entry burn is used to slow the first stage as it heads back towards our drone ship. Of course, I still love you.
Both vehicles are following nominal trajectories.
We're currently in our first MVAC burn, and this burn should last for another few minutes. And the next milestone will be the first stage entry burn, coming up in about 2 minutes. Now today, Falcon 9 is performing 2 burns in order to land. The first burn, known as the entry burn, slows the vehicle down before hitting the denser parts of Earth's atmosphere. And without this burn, we'd only be using the atmospheric drag to slow down Falcon 9, which would add extra stress to the vehicle. And then following entry burn, the booster will initiate the landing burn, which should slow the vehicle down even more for a successful landing. When Falcon 9 fires up the center M1D engine for re-entry, the vehicle will be flying through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle surface. And you'll see these marks across the flight-proven Falcon 9 first stage fleet. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little bit more on the outside of the vehicle. And the first stage supporting today's mission is making its 12th flight right now. It previously launched the SDA-T1TLB and SDA-T1TLC missions, as well as 9 Starlink missions. We're under a minute away from the start of the entry burn on the Falcon 9 first stage. And you can check out the telemetry on the bottom of your screen. And we can see that that second stage is still picking up speed and heading towards its destined orbit. So we are coming up now on the beginning of the entry burn. You should see the graphics light up as the engines do on the bottom of your screen.
Stage 1 entry burn startup.
Stage 1 FTS safe.
And there was the call out for the entry burn startup on the Falcon 9 first stage. This burn is set to last about 25 seconds and again is slowing the vehicle down in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And that concludes our entry burn. As mentioned earlier, we will be attempting to recover this booster, and today that booster is targeting a landing on our drone ship, Of Course I Still Love You. You can follow along with the burn in the engine graphic at the bottom of your screen. And as the burn happens, you'll notice a decrease in both speed and altitude. And then during the landing burn, we are expecting the shutdown of the second stage MVAC engine. This is known as Second Engine Cutoff 1 or SECO 1. We're still around 30 seconds away from the beginning of that landing burn. Again, this is the final burn of the Falcon 9 first stage.
Stage 2 is in terminal guidance.
Before landing on our drone ship.
Stage 1 landing burn.
And there you heard that call out for a landing burn start on the Falcon 9 first stage. Again, this is the final burn that this booster will execute before touching down.
MVAC shut down.
Stage 1 landing leg deploy.
Nominal orbit insertion.
Stage 1 landing confirmed.
Stage 2 FTS safe.
And as you saw and probably heard, we had a successful first stage landing and successful cutoff of our second stage engine and the call out for good orbit. So coming up next, we have the second burn of our MVAC engine on board the second stage, or SES2, around the T plus 51 minute mark. And then the first batch of deployments today will begin at about T plus 54 minutes. We'll be back at about T plus 50 minutes to bring you live coverage of SES2. So until then, enjoy our space tracks, and we'll see you soon.
got there, 25th century AD. We sat there and looked at the rockets from Mars, and you just boggled the mind. And the technology caught up, didn't it?
Welcome back to our live coverage of the Transporter 16 mission. It's been a great launch and overall mission so far. We had an on-time liftoff at 4:02 a.m. Pacific, and we recovered the first stage on our drone ship, Of Course I Still Love You, for its 12th launch and landing. And we had a successful first burn of the MVAC engine on our second stage. Following that, stage 2...
MVAC ignition. MVAC shutdown.
And there was confirmation of a successful second burn of the MVAC engine on the second stage.
Nominal orbit.
And confirmation of good orbit. And with that burn complete, we are expecting to start our first wave of payload deployments shortly. There are 119 payloads on today's flight, including CubeSats, microsats, hosted payloads, a re-entry vehicle, and orbital transfer vehicles, carrying 8 of those payloads to be deployed at a later time. We're expecting a total of 82 separate deployment events today, and for this first batch coming up, we're expecting 49 deployments. So these payloads will individually separate from Falcon 9's second stage, one right after the other, and we should hear callouts as the payloads are being deployed. Right now we have some beautiful views of the Earth if you look underneath our payload stack.
Luna 2, separation confirmed. Femto 1, separation confirmed. Jack 2, separation confirmed. Decimal Sat 1, Vega Fly 1, Hades Spinny 1, separation confirmed. Hermes 1, separation confirmed. Virion 2, separation confirmed. Cosmo, separation confirmed. Irmis 2, separation confirmed. TES 23, separation confirmed. PeakSat, separation confirmed.
Saley, separation confirmed.
Irmis 3, separation confirmed. Bro 19, separation confirmed. OptiSat, separation confirmed. Paris TX, separation confirmed. T Microsat 2, separation confirmed. Spock, separation confirmed. Virion 1, separation confirmed. Disco 2, separation confirmed. Sarja Sat 2, separation confirmed. Phobos, separation confirmed. SM 1.2, separation confirmed. Harbinger, separation confirmed. Out of the box, separation confirmed. NewSat 54, separation confirmed. Emisar, Igonsat, Troop F3, separation confirmed. Lilium 4, separation confirmed. iRide MS1 Eaglet 29, separation confirmed. iRide MS1 Eaglet 213, separation confirmed. ASAT 4, separation confirmed. iRide MS1 Eaglet 29, separation confirmed. iRide MS1 Eaglet 213, separation confirmed. Ghost Rider, separation confirmed. iRide MS1 Eaglet 210, separation confirmed. iRide MS1 Eaglet 216, separation confirmed. iRide MS1 Eaglet 211, separation confirmed. Dream Big Constellation, separation confirmed. Innosat Unamuno, separation confirmed. iRide MS1 Eaglet 212, separation confirmed. iRide MS1 Eaglet 215, separation confirmed. FGN 100D3, separation confirmed. Momentous Vigoride 7, Nomad Ride, separation confirmed. Hotsat 2, separation confirmed. NewSat 53, separation confirmed. Hawk 14A, separation confirmed. Spacefan 2, separation confirmed. Vardas W6, separation confirmed. Ion SCV, Astounding Alexandra, separation confirmed. Hawk 14B, separation confirmed. Hawk 14C, separation confirmed.
And with that call out for deployment, that brings us to the close of our first deployment sequence. For now, we are going to coast until the third MVAC relight, or SES-3, which should occur at about T plus 1 hour and 41 minutes. So until then, enjoy the space views and the space jams.
there and look at a rocket from Mars, and you just boggle the mind. And the technology caught up, didn't it?
Welcome back to our live coverage of the Transporter 16 mission. If you're just joining us, we're continuing to have a great mission today. Just to recap, we had an on-time liftoff at 4:02 a.m. Pacific, recovered our Falcon 9 booster for its 12th landing, and we've completed 2 separate second stage burns. We also saw the first deployment sequence of 49 payloads, and we now have 33 more to go. Coming up shortly is the third relight of our second stage Merlin vacuum engine for a roughly 1 second burn.
MVAC ignition and shutdown.
Nominal orbit insertion.
And that's confirmation of a good orbit following our third burn of the MVAC engine on the Falcon 9 second stage. And with that call out, we're going to take a break before a 4th second stage engine burn, followed by deployment of Gravitas, manifested by K2 Space at about T+2 hours and 16 minutes. So enjoy some more space jams, and we'll see you back here in a few. Hello, everyone, and welcome back to our live coverage of the Transporter 16 mission. We're currently just about a minute away from the fourth burn of our Merlin vacuum engine on the Falcon 9 second.
Nominal orbit insertion.
And there we heard confirmation of that fourth MVAC burn. The next payload deployment should begin in just about 3 minutes. In case you're just tuning in, we had an on-time liftoff at 4:02 a.m. Pacific and recovered our Falcon 9 booster for its 12th landing. After the first batch of 49 deployments, the second stage had a third successful ignition, and then we just saw that fourth MVAC ignition and cutoff. So now we're standing by for the next payload deployment, Gravitas, manifested by K2 Space. We are about a minute away from our expected Gravitas deployment.
Gravitas, separation confirmed.
Thanks for flying SpaceX, and we wish you well on your journey. And with that, we have one more wave of deployments coming up, and that is expected to begin at about T+2 hours and 25 minutes. So we'll see you back here after a short break. Hello, everyone, and welcome back to our live coverage of the Transporter 16 mission. We're currently just about a minute away from our final payload deployments for the mission. There are 119 payloads on today's mission, including CubeSats, microsats, hosted payloads, and orbital transfer vehicles, carrying 8 of those payloads to be deployed at a later time. We've already deployed 50, and so that leaves us with 32 to go. As we mentioned earlier, a full list of the payloads on today's mission is available on spacex.com/launches. And in case you're not familiar, our transporter missions are dedicated rideshare flights to sun-synchronous orbit. Falcon 9 is also launching the bandwagon missions, which are a separate line of rideshare missions that deliver spacecraft to
Flylab 2, separation confirmed. Lemur 2, Sejong 3, separation confirmed. GEMS 2, Amethyst, separation confirmed. Black Kite 2, separation confirmed. Lemur 2, Arena, separation confirmed. Unicorn 2R, Unicorn 2S, separation confirmed. Flylab 1, separation confirmed. Lemur 2, Clara, separation confirmed. AE-1A, separation confirmed. Lemur 2, Julia Joel, separation confirmed. N1 Atlas, separation confirmed. Lemur 2, Deloitte 2, separation confirmed. IO-1, separation confirmed. Toro 3, separation confirmed. Lemur 2, Polo 11, separation confirmed. Fossasat 25, separation confirmed. Lemur 1, separation confirmed. Lemur 2, Peggy 2004, separation confirmed. Lemur 2, Deloitte 3, separation confirmed. Lemur 2, MRCS, separation confirmed. ISI 1, separation confirmed. Lemur 2, Carolina, separation confirmed. ISI 3, separation confirmed. ISI 5, separation confirmed. Vindler 2.0.2, separation confirmed. CERT 3, separation confirmed. ISI 4, separation confirmed. Acadia 10, separation confirmed. ISI 6, separation confirmed. Vindler 2.0.3, separation confirmed. ISI 2, separation confirmed. Vindler 2.0.1, separation confirmed.
All payloads successfully deployed.
And with that confirmation, we've successfully deployed all Transporter 16 payloads. It has been a long mission, but it's been so worth it to see all of those CubeSats, microsats, and orbital transfer vehicles now in space. We would like to thank all of our rideshare customers for entrusting us with their spacecraft today. And we also want to say thank you to the Range and Federal Aviation Administration for their support, and to you, our viewers. To date, SpaceX has launched more than 1,600 payloads to orbit across our entire rideshare program, and there are lots more to come. A full listing of today's payloads can be found at spacex.com/launches. And for more launch coverage, be sure to check that same site for the most up-to-date information, or follow us at SpaceX on X. And with that, we'll be bringing our webcast to a close. Thanks again for joining us.